I can. We can. Hello, computer. Hello. I'm here for real now. Well, I'm not here for real quite. This is still pre-recorded. Hello, but I'm no longer imprisoned by that foul pretender. That foul pretender trapped me in my meditation plane, and I was unable to escape for a good 20 minutes there. But now I'm free. Hello again. It's me for real this time. I hope you're all doing well. I'm very sorry that I can't greet you today and say hello, but best wishes to all of you in any case. I should probably explain the situation. Yesterday on Monday, Maud had surgery. It's a minor thing, but she had surgery, and she's been pretty out of it ever since. So because of this, I'm taking the day to take care of her. But because I had advance warning, I didn't want to leave, I didn't want to do nothing, right? We have to do some little thing. So today I don't know, I'm going to look at elf stuff. And yeah, it's just going to be me here. I know you're all supporting me morally, in a moral sort of manner. And we'll regroup on this again on Friday as normal. Hello. I guess I can also say it's a little less awkward because it's... we're not live. Thank you so much for all of the support always, my friends. It really means so much. I really can't believe that I can do this as like I don't know. It's hard to express how I feel about it even, but thank you. Without your support, I would be adrift at sea. So thank you so much, and thank you so much for all of the boosts and all of the I don't know, anything, all of the well wishes. It's really nice. I'm feeling very good about the computer. I'm feeling I don't know. When I was recording this, it made me realize, like, I was trying to get excited about all of these fake people, about Upside Down Noodle, and about Celerity VT and Drasco Tabasco, but I really don't want to be excited about those people. I want to be, I don't have any feelings towards this. I want to be excited about Sun Demoniac and Niche Penguin and A Squared 31415 and Exor Xavier and Wind Up Boy Fade and the whole crew, Bonmus and Rosie Liz and everybody. I can't name everybody, and now I've put myself in an awkward position where everybody I don't name is gonna be like, well, you forgot about me. Well, okay. Imagine I named everybody. I know. Thank you so much. But we do have a project today. There is some meat for this candy. There is a little bit of meat for this candy that we've done so far. We're gonna look at Elf a little bit. That part's real. I stayed up way too late on Sunday night looking at Elf. This is something we've talked about a bunch on the stream. Linkers and loaders and object file representations. This is a kind of an interesting topic in general. It's how code is represented and how code is manipulated in this way. I don't know. It's an interesting thing to me, at least. And I've never really had a good grip on it. Right, as LCOLONQ, my nemesis, was claiming in the when I was possessed. I've never really had a good understanding of what makes like a relocatable object file, right? Like something that GCC just produces when you pass in -c, different from an executable. Like, what is the difference, right? Like, I know some things about working with ELF files, right? I know I can obj dump them, right? Is it -t to list symbols? I can obj dump them to see the symbol table, right? But I'm sure I can do this for, this guy. Of course, there's less symbols here, but like, what's the deal with all of this, right? Like, how does it all come together? I assume there are more here because it's linked with libc, but like, there's all kinds of things I can do. So let's get a little better of an understanding about this together. Let's try and work out what the deal is with these goddamn elves, and maybe also write a little program that manipulates them. I'm thinking, I don't know, maybe we'll write something that maybe outputs a simple binary, or like something like maybe we'll just look at the headers, right? We'll make something that ingests an ELF file and prints out the headers, maybe dumps the symbol table or something. I think this is pretty accessible to do, and I don't think so. Let's do it. One thing I was surprised about when looking at this thing is ELF actually has a super nice standard, Like this is the 2025 standard document, and this document is really shockingly good. Another thing I didn't realize is that ELF is actually part of like the system V system, whatever you. I think it's system V. It's not system 5. It's system V. We're saying system V, whatever it actually is. Or is it, I get this mixed up. Like there's RISC V. Do you say RISC V or RISC 5? Is it system V or system 5? Who knows? We've looked it up, but I'm going to get it backwards every single time, regardless. So what do you? I don't know. But it's part of the ABI. Like they specify ELF, and there are interesting things about this. Like I saw mentioned somewhere in here. Apparently, there's not an affordance in the API, I guess, or at least it sort of implied that there wasn't an affordance for statically linked programs at all. Like it was implied that all ABI compliant libraries dynamically link in the libc in order to provide access to platform stuff, OS stuff, which is kind of funny. I don't know. So anyway. They talk about this stuff, right? So they start right off with the point of my confusion, which is what's the deal with these different kinds of files, right? I have an ELF file for my .o, I have an ELF file for my .so, I have an ELF file for my executable, right? And they make the distinction here, right? Where a relocatable file, this is like a .o, has stuff that is for linking against other object files to make an executable or shared object, right? So this is kind of the focus of the contents of this file are on linking, right? Linking, like compile time linking sort of stuff. I say compile time meaning before runtime, after compile, you know what I mean. You know what I mean, computer. Man, it's so strange doing this without anyone to talk to. This is I don't think I like it very much, to be honest with you. It's a little bit scary, but we'll it's been a long time since I've done this, but we'll keep going. We'll keep going regardless. Somehow I want to do this. I like ELF. I love ELF. The feeling of it being 11:11 on the clock in middle school and staring at the clock and being like, damn, I wish I was an ELF. This is some would say core. In an executable file, we know what this is, and this kind of specifies how the system creates a program's process image, right? So we kind of have like here's the distinction, right? Like a relocatable file, a .o is for the contents are for linking to make an executable or a shared object. An executable, the contents are for loading, right? For creating the process image in memory, like populating the virtual memory for the process. I think this is how this works, right? Populating the process's like memory space with the appropriate bytes. And a shared object file has code and data suitable for two contexts, right? So it can be something that can be linked ahead of time with with other shared object files and relocatables to make an executable or another shared object, right? This is like, if I pass in -l raylib, dynamically link in raylib or something, right? This is my executable file knows something about the symbols in whatever libraylib.so, right? And it can also be used at load, like when something is loaded, right? The dynamic loader works with this thing and loads it into like the memory of a process, right? And I think there's like interesting stuff that happens there, right? Because they try and like share this, or it gets loaded. I don't know how it actually works. I think they try and reduce memory usage through this somehow, right? Like probably like it's like I assume it's something like the pages, the memory where the like all of the pages where the shared object lives get mapped somewhere in the executables, like in the process's address space, right? And it could be a different spot, which is why shared objects need to be positioned independent. I think something like this. I don't know. We'll talk about what all that means. Maybe I don't even know if that's true. Correct me if I'm wrong. Send me DM. Send me DM if I'm wrong, please. Thank you. Okay. So the structure of an ELF file is not that complex, right? Here's a little diagram, and they kind of describe two views of the file. And this is something that's always confused me, and we'll get to that a little bit later. But the file always starts off with a header, right? And the header is pretty simple. They also tell us very nicely, like what they have little types as basically C types and what all their sizes and alignments are, right? And it's pretty simple. These guys are just like, fixed size, signed or unsigned integers, and this is not bad. And there's some accounting for endianness as well. But yes, can we see the header? Yes, here's the header as a C struct, right? So we have a bunch of fields, right? The first field, this eIdent thing, is like various things about the file, right? Like how to parse the rest of the header and also other things, right? So like it gives you like magic numbers at the start, right? And also a bunch of other, we'll look at that more later. The second thing is like the object file type. So like whether it's a .o, right? etrel, or a value of 1 here is it's a relocatable file. etexec means this is an executable. etdie means it's a shared object. I don't know what a core file is, to be honest with you. They say it's reserved. I don't know what this is. And these are all like ranges of permissible values if you have like OS specific or processor specific object file types, which is kind of cool, right? I think that kind of rocks. I don't know, like I know there's some affordance for like I don't actually know how like the object file stuff works for WASM. I know that I think they maybe are in ELF. I don't know how this, I don't know. I would be interested to see like what a processor specific guy in this field, or if this is even something that's in common use. We would have to, if you have examples of this, please share. I'll yell at me on Friday, make a little sticky note or something. And we have machine architectures. There's a bunch of things. They have a big list of these, and they're like, email us. Email us if you have an architecture, and we'll give you a number. And they're getting up there, but they, I mean, they have. I think this field is quite big, right? Like this is e-machine is it's a machine word, right? It's either 32 or 64 bits here, so they have a ways to go before they fill up. And then the ELF file version, which there's only version 1 without extensions. Entry point, we were looking at this a few streams ago, I think back in like January or something. We had some investigation of like where does a process actually get loaded, which I guess this is supposed to be, I guess in so typically the address of like _start, but I guess it's just convention to call it _start, right? It's just, that's just something that probably tells the I don't know what causes this to be typically populated by the linker, or maybe the linker recognizes the symbol _start, like, and says, okay, this lives in the symbol table, and then therefore we're going to put this in as the entry point address. I don't know. We'd have to look a little bit, but that seems plausible to me, maybe. Then various offsets into the table of in the file of other tables, right? So the notable things are the program header table and the section header table. And we'll look at those in a minute. And we have various, like the size of the file, the size of the header in bytes, various flags, various size of entries in those tables, right? So sizes of each entry and number of entries. This is kind of nice because the entries are all the same size in these tables. It's kind of good, right? Like you sort of expect these things to be, I don't know, maybe it's just the idea. I have ELF in my head associated with, well, I'm working with ELF on my my normal computer. This is going to be an x86 computer, and I just instantly assume that everything is going to be like have the flavor of x86 instruction encoding, but I really shouldn't assume this at all, right? Like things can just have nice fixed sizes. It's not horrible. We don't live in that kind of hell yet. But yeah, you get the gist of this, right? It's not too much. It's not too much. So why don't we try and read just the header if we can, right? I mean, we have basically C structs for both of these guys, right? We can certainly do this if we want to. Can we go to ELF? I have a little empty C project here. Doesn't do anything yet. Can we pop open something? Can we pop open a guy here? Let's call this elf.c. Let's make another guy called elf.h. Can we do a little the usual business, the usual suspects? Let's say I'm trying to prefix my stuff now, right, in order to avoid any collisions if we keep writing a bunch of C. I don't know. We're gonna try this way. Let's see what's up with this. So, and can we also get types? I don't want to cause any difficulties. Can we get utils.h? Let's grab those as well. These are types I've been defining everywhere. I kind of want to use these types. Can we steal them from Gastro, actually? I want to like plot these types into like some common library that all of the things use, to be honest. I think this would be much nicer than just like in the long run, if we have a bunch of these projects that are all talking to each other, we probably, I don't know, I guess if they're the same type defs every time, it doesn't matter. Like I think you can make the same type def multiple times. That's like a thing that's legal. Maybe. Can we put this down here? Like if I copy this, will it yell at me? Will you yell at me? Can I put this in elf.h actually? Do you hate us if we do this? Yeah, okay, can we also make sure that's in the makefile? This is, can we get this? Source elf.c. Can we do this? No thing for build elf.o. What the hell is wrong with you? Do we save that file? How do I do this? What do I usually do in my makefile with these guys? Oh, this guy's wrong. This guy's wrong, this guy's wrong, this guy's wrong. Because I'm doing a new thing. Let's move all of this shit down, actually. I'm doing a new thing to try and put like do compiler specific C, like I'm trying to prefix the build directory name with the C compiler, right? Just to, you know, make some things a little bit nicer. If we're swapping compilers a bunch, right? If you're using Colonq sometimes and muscle GCC some other times and GCC some other times, I want to make it a little bit nicer. Okay, this is just, we don't have standard int. Not here, over here. That's where we go. Oh, it does yell at us with wpedantic. Okay, sure. Well, either way, we'll probably want to eventually factor these guys out, like this common utils file we've had everywhere. But it's not pressing right now. I don't want to. I want to mess with elf. I don't want to fuck around with doing this in Nix for 25 minutes. Ideally, we go a little bit elf mode on this. So I guess there's a question of how we're going to actually work with the files, right? I think the way elf is set up, probably intentionally this way, we probably don't want to just load the whole file into memory, right? Because that's sort of an easy thing to do, right? We could just say, hey, take this file, you know, determine the size of the file with ftel or whatever, the fseek, ftel kind of stuff, right? And then make a bit, like malloc a big buffer of this size, load it all in the memory. This might be the easiest thing to do, actually, and it might still be good. But I think elf is set up in such a way that we don't have to do that if we don't want to, right? Like, it's like the kind of parsing that we want to do. I mean, I guess you never have to do this, right? You can always just sort of, but like I think it's the sort of thing where you know, you could we could just fseek to the positions that we need and read things of exact sizes and deal with this, which might be kind of nice. I don't know if it's probably slower to do this, right? Like doing a bunch of syscalls to move around the guy, but I don't know. It's kind of appealing, right? It's a little bit appealing, at least. One thing that's not appealing about it, I guess, is that it wouldn't generalize as well to settings where we don't have, you know, file IO, right? Like I would sort of like my parser to be usable in either setting, right? Really, what we would need is to make this generalize is some kind of abstraction for like a random access buffer or something. I don't know, right? Like something that we can like jump around in and read bytes of certain lengths from, right? And that could be either a file or just like a memory region. So I don't know. I think actually probably the nicest, let's just do it on the memory region at first. Let's just load the whole thing into memory, because I think it's probably going to be much faster in most cases. And also, like, we're never going to work with elf files that are big enough that this is going to be annoying, probably, right? Like, we're fine loading the largest possible file we're going to work with is going to be like a gigabyte, maybe, if we're like working with some gigantic Rust thing with debug symbols. And like we can do that. We can handle that if we really want to. And if we can't, we can always just like make our own new thing. Okay. So let's start by just like reading the file. Is that a thing? Is that a thing we can do? Get a little helper guy? let's see. Let's fucking see. Can we do this? Let's just call this, I don't know. We don't really need this guy to be Let's call this guy, I don't know, static void or static U8 pointer reads path, right? And this will just read the path P. How do we do this usually, right? Probably something like this. Probably something like let's do a null check also. If not P, return null. Blah, 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 blah. We'll have some file F, right? We'll say F equals F open P read, right? This is how this guy is, right? You give him a mode. And then we want to determine the size, right? We're gonna have some sizes going on. How do we determine the size? Let's say I64 len equals 0, right? To get the size, we can fseek on F to the end of the file. Fseek has like a guy it has offset and whence, right? I can say seek to 0 offset and whence is seek end. This is the kind of thing. Fseek 0 seek end, right? We're gonna need why does this not give a, oh, there we go. We had to reload the file because of, you know, classic sort of issues. Can we get standard lib.h? Can we get standard def.h? The usual suspects, please. Can we also get standard io.h for file? Okay, very good. Seek to end, and then ftell I think gives us just gives us the position as a signed integer from a stream, right? And then we can, you know, we can after this we can say len is ftell. We can say fseek f0 seek, what is it? Seek set, I think. Seek set is relative to the start, right? Because it's just setting to the, kind of awkward that it's and then set. You know, this is how it is. Okay, we have our length, right? And we're just gonna chuck this guy on the heap. We're not too worried about it, right? We're just gonna say u8 pointer ret equals null. Ret equals calloc. Which direction is it? Right? It's blah 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 blah. It doesn't matter, right? We'll say it's calloc len size of u8, and then at the end we'll return ret. But we want to read also, right? This is going to yell at us because we're casting implicitly casting to size t. We'll just do this explicitly instead. And this is something that's bothering me a lot about writing C. Like, it feels the situation with what integral types to use and also with overflow makes me very, very nervous. I had never really considered these issues before, like, but I've sort of gained a growing sense of unease around a bunch of topics like integer promotion. Like, I have the sense, I haven't really written out, I should probably write an example. Maybe it doesn't happen in practice, but there's like just like any addition or multiplication can just like be undefined behavior. I guess it doesn't really matter because like the compiler is just going to assume that it isn't, right? But it's just kind of, so unless you're like trying to like rely on checking that it isn't, right? And then this is something the compiler might obliterate from your underneath your feet. But it just feels very like, I don't know. It's a nervous feeling thinking about this. I don't feel like I have a good grasp of what to do with this, and it's made me nervous every time I write a plus or a multiplication. Multiplication in particular is just very. I guess there's like that checked math header in C23, but I don't know. Well, this is kind of much more annoying to use. I guess I probably warrants just thinking harder about, you know, checking inputs and making sure things don't overflow in the first place. Maybe I don't know. Who knows? Anyway, we want to f-read this guy. We would quite like to f-read him. What are we doing with this? What are we doing with this fuck? What are we doing with this nasty fuck? Can we load them? Can we load them up? We probably also want to indicate some kind of way to that we're like I don't know. Like what the size of this guy is. Let's make this not just return U8, right? Maybe we want this guy to be a little more. In fact, I think that's probably what we want. Let's make a new guy. Let's call this guy elf context. Or let's call it elf buff, maybe. Elf buff. And what is an elf buff? Well, an elf buff has the buff. It's got the buff in there, and also has the length in there. Let's get this guy. Let's get this guy. He has a buff. He has a len. This will like live at the heart of our elf processing things, I guess, right? And we'll eventually, I think, wrap this guy with some other guys who we'll see how we're gonna design it. I don't know. Probably poorly the first time we do this, but you know, you never know. Let's say we have an elf buff rets. This can be buff. We want to f read into buff. If we can get away with it. If we can get away with it. And we can't really conveniently return null for now. But we can say, let's just say here ret.buff equals null. Ret.len equals -1. This will be like our error signaling thing, I guess. I don't know. We don't really have a good... We like... With this kind of stuff doing IO, we probably just want to exit. But like, whatever. We'll deal with it for now. Let's f read, which this guy wants destination element size, number of elements. It's the reverse order of Colonq, which is why I'm always checking these fuckers. And like, sure, size of U8 is 1, but like whatever. This guy wants buff. This guy wants buff. He wants f, or he wants size. He wants size of U8. He wants size t len. He wants f. This is his shape. And then we say down here ret.buff equals buff. Ret.len equals len. Return ret. Okay, good. Let's try running this guy, I guess. Can we pop open main? We're gonna try and like, I really like just like running the code a lot. You've probably noticed this if you've been watching the streams for a while. I don't know. Maybe I'm a freak for this. Like, I want to run the thing all day. This is where I am. Can we make this guy take just take an argument? That's probably the nicest thing. argv shush. Can we say, okay, if argc is less than 2, we want to fprintf standard error usage elf path. I don't know, something like this. I don't know what the convention is for these things. There's all kinds of fucking brackets and things. Pass in argc0. We're gonna assume, or argv0. Shush. How do I not know? I don't know how to do anything. I'm a fool. And we'll return 1. Let's do this. It's so strange doing this on my own computer. I hope you're doing well. I feel awful. I'm probably going to be in the chat room responding to things. I just didn't want to like keep Maud up with my yapping, but she's been really not feeling great. Like yesterday, she was like, she passed out. I don't know. I've been very nervous. I've been so I want to disturb her as little as possible. Please understand. I know you will. Okay. And as they say, this is a normal stream. We have this, we have the path. Let's just say elf buff e equals read. Let's call this something else also. Like elf loads from path. I don't know, something like this. Give him a very clear name. Because the intention is that we can both, and the reason why we're gonna work on the thing in memory is it makes it a little bit easier to like both, like, all our code will just work on this elf buff thing, and we'll be able to create this either from an existing buffer and a length, or from like, hey, load this file from disk and get me all the goodies out of there. Get me the freaking goodies. Elf load from path argv1, and then can we see what this is about? Let's print some stuff. Let's print is it, if I'm like e dot len, what are you all about? What's your freaking deal? Oh, and shush. We're living in C89 land. C89 land still because of memes. Can we say elf? You're gonna tell us we don't know. What about if I run you on yourself? What do you say? Well, you're 47456. Does that match up with reality? Well, yes. Okay, good. We can load the file. That's a good thing. We're getting the right length and stuff. Can we, we can check that this is an elf file, presumably, right? We can check what the elf header says, right? Because if we look at the header, we look at this document, right? There's this ident thing is the first 16 bytes of the file. If we look at the description of that thing, the first 4 bytes, these mag0, mag1, mag2, mag3, are a magic number, 0x7felf, right? And if we look at our elf file here, right? If I go hexel mode, right? You can already see it here. You can see it's 7f and then elf, right? So let's just check that to make sure we're loading the thing correctly. That seems fine. We can check a couple of bytes at least. We should probably check the result of fread also, just to make sure, right? Like fread returns I mean, I guess we can just say if fread, or if len is not equal to fread, right? Because it should read the length. If it doesn't read the length, right, we should just return. We should free buff first. We also need to fclose here. Fclose f return ret. What are you yelling at us about? This is the wrong. Okay, yeah, size t len. And down here we also want to do this stuff, right? We want to free buff fclose f, right? Honestly, if we're just always doing this, we get to cheat a little bit, maybe. I don't know. This is not bad then. I don't hate doing it like that. And this is a pretty reasonable thing to do, maybe. We don't do this here because we haven't opened the resources yet. Okay, not bad. Either way, let's check the start of the file. Let's just print out, like, I don't know. Print this as hex. Print this guy as hex, and then print character, character, character. And this will just be e.buff0, e.buff1, e.buff2, e.buff3. Okay, this builds. Can we run it? Segfault core dumped. Classic. Classic moves. Are we ending up in a position where, we don't need to free buff in that case. Our own, we're trying to get tricky here with our little go-to nonsense, and this isn't correct, right? It's not real. Can we do this? We're good. Yeah, wow. It's what we expect. It's what we expect. Very, very good. Very good. Cool. Can we try to parse out the header then? That seems like a good thing to do. I think the way we're going to structure these is we're going to have a variety. We're going to have this like core elf buff guy, right? Which is just the buffer and the length, right? There's really nothing to him. And then we'll have a bunch of different things that just like query that, basically, given other information, right? Because like a lot of elf is just saying like, okay, this table lives at this address, and inside of this table there's the offset of some other table that lives at this other, and there's an offset in the header. There's an offset to the section table, which has a bunch of entries, and the entries in the section table say that this section starts here, right? And they're just giving you addresses inside of like the whole file, right? So I think it might be nice to just kind of not like parse ahead of time, like say, okay, given the file, produce, you know, if I was writing Haskell or something, I would want to write a function that takes the file, right, as a byte string and produces like Haskell records of the whole file, right? But I don't think that's what we want to do. And it's also like, it kind of, you know, there's going to be a lot of parts of the file that we don't care about, right? And in fact, ELF files, a kind of a cool thing about them is that they can just contain other data. I hadn't really realized this, right? But like the ELF file, the core of it is, right, is you have this section table that then says, okay, here's the sections. They live at these addresses, and they like they're this long, but they don't have to be like, there can be other stuff in the file, right? Like you can just like, you know, either as padding, which is like the thing that they mention, or like so I'm kind of been thinking, like, I wonder if we could structure something to be both an ELF file and something else, right? Because an ELF, really the only core bit of an ELF file that's necessary is like the header and stuff being at the start, being at byte 0. But there are some file formats where like the header exists at the end, right? So like for example, zip is like this, I think. Zip file. And everything else in ELF, you can kind of put it wherever you want as long as you describe where it is, right? You can say, oh, here's the program, like the segment table, the program table, or here's the section table, right? You can put these guys, you just tell ELF where they are in the header. And zip, I think, like it's all of its metadata is at the end. Yeah, and before this is just, so I wonder if, and they mentioned the locations of file, and so I wonder, you know, this is like a trick people do a lot, where it's like, oh, like an exe file that's also a zip. So I think like for a self-extracting thing, but I guess I haven't seen this as much on Linux, but I guess you can probably do it. And I wonder if there are other cool tricks you can do as well. It seems like a potentially fun thing, maybe. I don't know. Anyway. We'll have to investigate zip some other time. So we're gonna want functions that look like, I'm gonna want a thing that populates a header, right? Let's make a guy called, I don't know, elf header. And I know there's like a standard elf.h file, right? That like for reading elf files, for like that defines all these structs and stuff from the standard. We're just doing it ourselves for fun and greater understanding, right? This is an area of like linker, especially like loading files, is something that I'm very like, well, I don't really know about this just yet. So it'd be good to figure it out a little bit. And I think our future, as I think I mentioned on Friday, is I would eventually like to apply some of our compilery sort of stuff to x86, right? This is going to come at some point. We're going to want to produce some x86 binaries. So, and just like being able to do, I don't know, it's just good to know about, I think, right? I'm sure you understand that too, right? It's just like we're running binaries every day, right? I'm running like 20 binaries right now. I'm making binaries. I'm telling my compiler to spit one out for me, like executables, I mean by binaries, right? We're making all these executables, all these ELF files all the time. I don't even know what the deal is with them, right? This is an intolerable state of affairs, right? I don't know. We got to work this out a little bit. So anyway, let's define this header struct, and we'll basically just follow the struct here. Can we split this in a manner that is tolerable rather than completely intolerable? Is this fine? This is a little bit fine, I think. Could be good. And you know what? We'll even define both of them. I think that's fine too. I don't actually hate that. We can do both even. Can we do this? Can we be fucking doing this? Let's just call it elf32 header. I don't know. Let's say this instead, right? And this guy is gonna look like, well, he's gonna have. Can we also say I don't know, define elf and ident here as they do. We have an array of these guys, ident, I'm gonna rename these guys just for our own purposes. So just like it's essentially pointless to do this, right? But I want to do it just to make sure that as we go, we're not just like copying things. Basically, we're not just being like, oh, we're getting this field, we're getting like I want to like, as trivial as these things are, I want to understand, right? And the types that they use here, we will also replace, right? So like, what is the type that they mentioned for? Yeah, half is a short. Half is a short, like half is 2 bytes, word is 4 bytes, S word is the sign equivalent, and then X word is 8 bytes. Okay, so half is, so I was wrong earlier about this being 32 bits of machine. It's only 16 bits of machine. It's fucking over. The I16 type, I16 machine. I think we should get the correct alignment constraints just from, it doesn't actually matter because we're not going to read this directly. We're not just gonna like read this whole thing because that feels like illegal, I think. I don't know if you can actually do this. We'll read it field by field, so it's not a problem. Can we we're not gonna read it anyway, you know what I mean? We're not gonna mem copy to a variable of the struct type because I don't think this is a good thing to do in general per standard C. I32 version, I32 entry, I32 program header offsets. I think these guys are all is off unsigned. Yeah, they are unsigned. These guys are all unsigned except for unless they specify signed. Yeah. Okay. Segment header offsets. U32 flags. U32, or rather U16 elf header size. Let's give them even like long names. Program header offset, section header offset, elf header size. Sure. Let's say program header entry size, program header entries, and then we have the same thing for section header entry size, section header entries, and then the last thing is the section header, which is something that we would probably like to rename for real. The this is the section header, the table entry in the index into the section header table of the entry associated with the section name string table. So sections have names, but the names themselves do not live in the section header table. The section header table basically just contains offsets, I think. Maybe this is and indices into another table, right? And that other table itself is in a section, right? So in order to find that other table, we have in the elf header, we have the index of that table in the section table. Yes. It's a little contorted, but it's, it is what it is. Okay, can we, and this is an offset as well. No, this is 16-bit, sure. Let's call this section header name table index. Or sure, this is fine. And we can throw some comments on here if we wanted to. I think for 64-bit, it's going to be basically the same, except we I think it's actually, is it actually the same? I think it's actually the same, except adders and offsets are bigger, right? This is the concept. Maybe we should type def these in order to. I don't hate that. Let's call this elf32 adder. We'll type this to U32. elf32 offset is also U32. And then similarly for elf64, these are now U64. And elf64 offset is now U64. And what things are adders and what things are offsets? Well, eEntry, this is an adder. ELF32 adder. And what else? What else do we have going on? These guys are offsets, right? ELF32 off. And that's it. It's just these. Everything else is just like a size or an index or something, right? And similarly down here, right? This is ELF64 adder. These guys are ELF64 off. This guy is called ELF64 header. This guy, we could probably use like a macro to deduplicate this with some, I don't really care though. It's fine, right? It's not like we're doing it any more than twice, right? It's, yeah. Younger me would have agonized over this, but I do not care that much anymore, I think. Okay. Okay, what's can we load one of these headers? What if we're like, what if we want to do something along the lines of, I don't know. I don't freaking know. Let's make a guy that returns I64. We'll have some kind of error concept here, maybe. I don't know. Let's call this ELF32 read header. This is not bad, right? And we're gonna take an ELF32 header pointer h, and we're gonna take an ELF buff pointer context. So what does this guy look like? Well, we just have to basically read this, right? It's not very complicated. It's just a matter of reading the guy. And there might be, is this set up in such a way that all of these guys have alignment restrictions, right? But I think it's set up in such a way that everything should be aligned, right? Like for example, if this machine was missing, we'd have to still account for it, right? Because how do you say, like the subsequent 32 probably, like this guy is 16 bytes long, so he's fine. He sufficiently aligns the next guy, right? This guy, right? This guy's fine. This guy's fine. If this guy, like, they're all okay, I think. Will be golden, even up to this, right? Because at this point, right, there have effectively been 3 64-bit regions, right? There's 2 here and then there's 1 here, right? So I think that's okay. Maybe not. Oh no, ELF6. This is the ELF64. And ELF32 is that the, yeah, it's also the case, right? We're good either way, right? We're totally good. Can we consider? Well, let's just write the guy. Let's just write the guy if we can. Do we have a dead white space there? Okay. So this just looks like copying all of the things. Did we not? What are we doing here? Oh, these are backwards because typedef. That's not how typedef works. Typedef goes the other direction in C. Okay, very good. Let's say some stuff. So normally at the end of this, we're going to return 0 for success, maybe something like that. I don't know. We can even say return true. Let's just say let's say return 1 and return 0 for failure for now. We'll think it doesn't really matter that much. No, well, 0 success. I like this. I like this a little bit. Or like non-negative is success, maybe even. That's not bad. We can maybe return something useful if we eventually need to. So this is easy. We just read directly from the start of the thing. So it's gonna look like a bunch of mem copies and assignments. This is not bad, right? This guy is mem copy from. Well, I guess we should also check the length. What is the length if size of well, I guess we can't really directly compare the length to the size of ELF header, because again, this could have, the compiler and the C compiler could put arbitrary padding between these fields, right? I think this is real. Maybe is this me just hallucinating this, right? Can C compiler insert arbitrary padding between struct fields, right? And of course I could use like an attribute and be like, pack this struct, right? But like I don't want to do that. Well, this just makes it not aligned. Like I know, like the fields have to be aligned. This is true. I don't want to know about like what the process. I want to know what the standard says. I don't think you can do. Oh, anyway, we'll verify this because it is somewhat annoying. Anyway, it doesn't really matter that much. Can we say h ident? What does memcopy want? It wants dest source size, right? We want context buff. We want 16 bytes. Can we get string.h on here? Sure. Let's say some stuff. Let's say some freaking stuff. Like we want to return -1 in a bunch of cases, right? We would like to return -1 if, well, I don't know, if not h or not context or context len is less than elf32 header size. Maybe something like this. Return -1. And we need this elf32 header size guy. How big is he? elf32 header size. Well, he's 16 bytes. He's 18 bytes. He's 20 bytes. He's 24 bytes. He's 28 bytes. He's 32 bytes. He's 36 bytes. He's 40 bytes. He's 42 bytes. He's 44 bytes. 46 bytes. 48 bytes. 50 bytes, 52 bytes, right? Does this line up with reality? If I were to go over to main and I were to printf size of elf32 header, what does that tell us about? Unsigned long, please. What do you tell us? You're 52, which is what we expected, right? Yeah. And the 64-bit version, well, it's the same thing except we have 12 more bytes, right? So it should be 64 bytes. These 3 fields are getting bigger by 4 bytes. This is maybe the idea. Let's just say that for now. And again, the reason why I don't just say size of here is because I don't think we have a guarantee that the thing is exactly that size, right? We have, you know, it probably is, right? I think it is, right? But like, we can imagine writing some fucked up compiler where that isn't the case, where we align everything to, you know, like I think the alignment is merely a minimum, right? It is not as a maximum, right? I don't know. Anyway, we're gonna assume that it is to satisfy our own freakish little desires. Let's okay, so there's ident. What about other things, right? What about other things here? Well, the rest of the header, we can't just copy memory willy-nilly anymore, right? Because of endianness. The endianness is a bit of a fucker. He has a bit of a fucker's nature. So what do we do with that? What do we do with that? And furthermore, it actually occurs, we may want to parse the ident before we do anything else, even. I think that might be worthwhile. because the ident allows us to identify whether the file is a 32-bit or 64-bit ELF file in the first place, right? So we can imagine wanting to make our some kind of tool that's generic over this, right? So we just want to read the ident at the start, which then tells us, okay, here's what the endianness is, here's what all the other business is, right? And then from here, actually parse the header. So let's kind of break off the ident stuff. Let's sort of treat this as something different, right? The ident instead will be a sort of platform, like a sort of agnostic header on the header, right? Let's do this. Let's say this is called ident size even. Let's rip the ident off of these headers entirely. Not like they have to correspond. Let's just call this elf ident. Elf ident. Maybe let's even call it elf header ident, just to drill it home in case we want to use this for like identifier. You know, there's other things we can imagine calling ident really if we think not even that hard. So let's say this instead. Let's plop these off of these guys, and then we're gonna require when we pass in. When we read this guy, we're gonna want to have an existing ident. Right, and then we'll use this to inform how we read it. Maybe, or I guess not. We don't need to pass this in, right? The only thing we really need it for is, I guess we do kind of need it, right? Maybe we should even throw the ident in the context so that we can query things about it easily. Because there's a lot of places where we're going to want to like read a number according to an endianness, right? And the endianness is specified in this ident guide, right? Like you can see here this EI data, I think it is. Yeah, EI data. There's data 2 LSB and data 2 MSB. I think this data 2 LSB is 2's complement little endian for signed integers, and this is 2's complement big endian are the current valid numbers here, and they give us a little explainer on endianness here. And this is going to come up again and again and again, right? We're going to need to know this for every single number we read in the file, which is another good reason why we can't just mem copy into the struct. Not least of which that this endianness is specific to the ELF target platform, right? This is not, they do it this way. Yeah, they say here, primarily for the convenience of code that looks at the ELF file at runtime, the ELF data structures are intended to have the same byte order as that of the running program, right? So if we want to, like, I don't know, produce some ELF file for some big endian machine, I don't know what big endian machine we would, like, are there any, is PowerPC big endian? Am I capping? Are we capping on this? Like what's a big endian character? Are there any of these that exist in modern times? Do we know anything about this? I don't know. PowerPC or early, okay, PowerPC are now bought. There can be both, I guess. They're configurable or something. As is ARM, as we have seen in unfortunate detail. I wonder like about the GameCube. GameCube's a PowerPC guy, right? I wonder what this guy is. PowerPC, this is what it was. This is what it was. Do we have any information? No, nothing. GameCube endianness. Here's GBDev wiki. This is the robot is telling us that it's big endian. Okay, here we go. This is someone at least claiming that the GameCube primarily stores data using big endian. Which is a little bit exciting. We're just gonna get a lot of results about the GameCube and stuff, which is, or the Game Boy rather. We want cube, not boy. So I think we're gonna want to do even better than this, right? We're gonna want to like identify the endianness and just like save this to the context. I don't want to have to pass around like 10 million fucking parameters to everything, right? I just want to have this context that's like, okay, here's all the data we need to read, right? This is what we need to read in ELF file. So let's maybe do that. Let's write a guy called, I don't know, type def enum elf endianness. Is this how you spell this typically? This is how I'm going to spell it. Let's Google it. Fine. Fuck. Yes, 2 N's. Elf endianness. And we're gonna have, I don't know. They're using 1 and 2 for this, right? Yeah. Let's say elf endianness invalid equals 0. Elf endianness. We locked. We've experienced the lock. Wait, did this kill my GPU? Did this kill my display? I think it did. Man, that's insane that this happens now. This hasn't happened for like ever. And now this is the time when it happens. Well, I guess this is convenient because I can, I guess in theory, edit it out even. Well, anyway, can I SSH into let's see what's actually happening here. Can I SSH into this machine? What does dmessage tell us? Do we get to see? Yeah, AMD GPU reset succeeded, which kills X, I guess, or freezes X. Very bizarre stuff here. Well, I guess we kill Emacs. Kill 9 does not even work. Well, we killed Emacs, but it didn't kill X, and X is still, so Emacs isn't even running anymore. It's just X sitting around. We have to kill 9X. Okay. Are we alive still? We're really getting the full stream experience today. This is unbelievable, kind of. This is slightly fucking unbelievable. Can we reconjure? I don't have the keyboard plug. One moment, please. Get this. Does this work? Does this work? I can't type anymore. You can run startx though. Okay. Very good. And bizarre stuff, computer. We just want to parse. We want to. Okay. Anyway, do this. Conjure up the man, please. Bring up the man. I'm not even gonna bother starting like all of the WASP stuff, right? We don't need it today. It's just kind of funny, right? I guess friend would be nice. We have to have friend. This is a sort of a legal requirement for the stream to be running. But the screen real estate. No, we're gonna keep friend. We gotta get friends. We'll load enough to get him going. Bring me back up though. Bring me back up. Let's do this. Reconjuration. Hello. Post I can't in the chat if you're. Yes. Yes. They made me too narrow. Now we're wide. Post I can't in chat room. Post I can't in chat room. Yeah. Okay. Can we restore ourselves? Continual restoration. Continual restoration, please. Let's get this. What is friends? Friends. Start. Friend wants the database to exist. He can live there without. Even if I stop this, he can exist without the database in peace. Let him be. Okay. We can navigate back to where we were. We might have. Do we lose progress here? We're losing proggers. Let's get over here. Let's go back to elf.h, please. No, we don't because Emacs is kind. Endianness little. is 1. Endianness big is 2. We'll write a bunch of things that like take these. I don't know. I don't know what the hell's going on here, computer. Elf endianness. Endianness. This is a relevant guy who's around. And when we load, we need to handle this when we do load from path. Now we're gonna need like a helper that we're gonna need something that parses an ident, right? Like another thing that extracts something that reads just an ident and various things that can extract various fields from. Well, I guess we could honestly just have a thing that I don't know. We'll see. What do we want to do? I don't know. Who knows what the hell we want to do here, computer? It might behoove us to in fact, let's get can we have elf.pdf here also? Elf.pdf. Elf.pdf. Yeah. Guy who's not going crazy. Guy who's normal. These are all just single bytes, which they sort of have to be, right? Or yeah. I guess there's no reason to have it just be an array of 16 bytes. Like, this is just totally pointless. We'll still have header ident size just to know how much to read. But I think what we actually want is probably I don't know, U8 class. U8. Well, if we do class like this makes this code unusable from C++, right? We probably don't want that, right? We want U8. We probably actually want elf class here. We're gonna want a variety of enums. This is endianness. Endianness. This is version we don't really care about, right? I guess we can still keep it around, right? We can take U8 version. I'm not even gonna bother enumerating these, right? Because I assume it's, you know, it's OS specific stuff, right? Like this is ABI. This is ABI version. And then we just have padding after this. But we need elf class, which I think this is whether it's 32-bit or 64-bit, right? Elf class. Elf class. What is the deal with elf with the class? Yep. It's either invalid, or so we can say elf class invalid equals 0, elf class 32 equals 1, elf class 64 equals 2. Very good. So we want a way to parse one of these just from bytes, right? Because our elf buff that we're passing around. Let's rename this elf buff fucker. It's not just a buff, it's a context. This guy, we're calling him a context. We love calling things contexts around here. This is classic stuff, real classic work. Well, anyway, we want a guy who can read a I don't know, elf. We want a guy that looks like this, right? Elf 32 or elf reads ident, right? And this guy's a little lower level. He doesn't require context to be read because we need to use him to create a context, right? So this guy takes a U8 pointer buff. He takes an I64 len. And he's actually going to take an elf ident pointer I also. What do we have? Elf ident or elf header ident? There we go. Okay, so this guy. Let's head over to elf.c again. Oh, does mod need something here? Mod may need something. I will go and get her. One moment, please. One moment, please. I'll actually stop the recording for now. I can do that. Wow, and I can edit it back to, it'll be like it's 0 moments. It'll actually be like it's 30 seconds. One second, please. Can we click this? Make sure to wiggle around a bit if you haven't been moving on the stream yet. We'll click this. Oh, there we go. We'll click this for now. I'll be back in 30 seconds. Thank you, computer. Thank you. See you soon. See you soon. Hello. Actually, Miss Maud is feeling very ill and is probably going to go to bed. So to avoid disturbing her, I'm probably going to wrap this recording up here. We'll continue all of this on Friday. Thank you very much, computer. We'll keep we'll keep tinkering. Hello, maybe I'll continue this live right after this happens. I don't know how things will go tomorrow, but I want to leave my options open. Thank you again so much. Thank you so much for coming by. Discord, IRC, go there. It's good to be there. I don't know. Thank you for everything. I don't know. Thank you. You're too kind to me. Thank you very much. Let's keep having fun on the computer together. Okay, bye for now on the recording that I'm sure I'll edit a bunch after this late into the okay, bye. Thank you. Love you. Bye. XO. Bye. I don't know who you're raiding, but raid message is Joel. Okay, bye.